if the same thing can be applied to software as the hidden price of software, if all we do is say, well, we're going to make software that sorts and searches and stuff, but it's a commodity, then we're losing the value of that software and a differentiating point for our company. You can't really differentiate your company using software if you're using exactly the same software, exactly the same way as another company is. This is a big problem today with our IT companies, where they don't value IT. They don't value it. They think of it as something that they have to do business, but it's not looked at as being a strategic product. They talk about total cost of ownership. And don't get me wrong, total cost of ownership is very important. If you can't afford the solution, you obviously can't go ahead. But even if you talk about enlightened total cost of ownership, the real total amount. Now, there was this company up in Redmond, Washington, that for years said that open source was more expensive than closed source. They said that because their products were well engineered and everybody knew them and used them and stuff, that they did studies and the actual total cost of ownership of proprietary software was less than open source. Recently, they commissioned a third party to do this study, and the third party published a paper that said, hey, guess what? Open source and closed source are about the same total cost of ownership. With open source, you typically did not have to buy the license up front. However, the cost of your support was higher because people who did open source commanded a higher salary, and because there were fewer of them. So I said, well, let me get this straight. If I'm an open source support person, I make more money than a closed source support person. Is this what you're trying to tell me, Microsoft? I mean, a large company who did the study. And in fact, it was. And so I say, well, this is why when I go back to university professors, I say, you can do the industry a favor by producing more open source support people so that we'll bring this back into parity again so that the cost of open source goes down. In the meantime, you're giving your students more of a chance to make more money because they're in greater demand and they have greater value. Now, here is what you really should be concentrating on. Once you get past total cost of ownership, you need to be talking about the value of the software. Does the solution meet your needs? And can you change the solution? And to give an illustration of total cost of ownership versus value, I have this little analogy. I go down to, how many of you ever gone down to the PC stores? There's this rack of $5 CDs, you know, and you go, oh, that looks pretty cool. You buy one, $5, what the heck? You take it home. So I went down there, did that one day, got the CD home, paid $5 for it, took it home, put it on my computer. It took me about an hour to install. Started it up, absolutely nothing. Didn't do anything. What was the total cost of ownership? $5 for the CD and an hour of my time. Went back to the store, saw another CD, paid $5 for it, took it home, hour of my time to install it, started it up. Instantaneously, the dog could let itself in and out of the house without me helping it. My wife came home, kissed me on the cheek, went into the kitchen, made me a fantastic dinner, took me upstairs, we made love the entire night. Let me tell you something, at the age of 60, that itself is a miracle. Kids came home from college the next day, all of them had straight A's, and the tax collector called me up and said, hey, guess what, we found an error in your taxes and we owe you $200,000, and all of it was because of the software on that CD. I submit to you that that software was infinitely valuable to me, and I don't care it cost me $5 in an hour of my time. That's the difference. Let's take a look at how this applies to modern day software. Here is two software problems. I mean, this is a problem. The left circle is a problem. And we're going to treat this. This is my business problem. We're going to treat this with proprietary software. I buy a big package of proprietary software. There it is. Oh, look. there's still some blue problems showing through. It hasn't fixed the whole thing. Well, that's okay. I'll go out, I'll buy another package of software and integrate that together. And, you know, it'll fix the problem. Oh, look, there's still more blue showing through. Well, I'll buy another package of software and integrate. Oh, rats. Oh, come on. I know. I'll buy SAP or PeopleSoft. And the problem here is it's so big and so massive that I have so much training for my folks. It's got so much functionality. What I'd really like to do is tailor that down. Make it so it really, really fits my application. But the thing is, I can't do that because I don't have access to the source code. Now, if you think that this is simply made up, I'll tell you about an Australian university that spent 17 million Australian dollars in 5 years with a large company that rhymes with MeepleSoft. And at the end of that time, they still didn't have an administrative system for their college. And the company said to them, hey, you have to spend another 5 million Australian dollars in another 3 years, and we'll have a vanilla version of it for you, not even one tailored to your needs. That's a problem. Okay. Now, here is an example from St. Petersburg. This is a turbine test bed. There are steam turbines. You feed the steam through them. It produces power to turn a generator or something like that. To engineer these things, it's a very complex process. And once the steam goes through, it still has some power left. What you want to do is be able to feed that steam back through another turbine, slightly different design. It takes a little bit more power out. Eventually you end up with water, and that goes back through the system again. But it's very, very difficult to design these without building a model and testing it. There's 5 of these turbine test beds in the world. 4 of them use closed source proprietary software, and this one in St. Petersburg uses open source software. And you can see right here that this is a little test, this is a little sensor to test the power and the steam temperature and things like that. This is where the turbine is put. And I have a picture of the software that the man produced with using open source. He used Linux as the operating system to run it. He used TickleTK so he could draw where he puts his sensors and everything on the turbines. He used GNU-plot to plot out the results, and he uses Apache to deliver this to all of the engineers all over the world who are his customers. I mean, this is not for him. He sells his services of his turbine testbed to engineers all over the world. Now, the other turbine test beds, when the engineers come back and say, gee, we'd like to have one little change done to the software, it could take up to a month to have them get the proprietary company to generate that change. He could do it overnight. So what is the value of this software? The value of the software is the fact that he can give the engineers the change they need to do their job overnight versus the other ones saying you have to wait a month to get that change. In Brazil, the lottery system used to be run by a proprietary software produced by a proprietary company. The Brazilian government paid $1 million a month maintenance on that software. Every time they wanted to have a new lottery game, it took 10 months for the company to implement the new game. They switched to free and open source software. They hired a team of 3 programmers to maintain it. Now when they have a new game, it takes them 3 weeks to deploy the new game. Do you know how much money a new lottery game generates when you have it 9 months and 1 week early? A lot of money. Not just a lot of money, I mean a lot of money. So again, the value of the software is not intrinsically linked to the software itself, but to the effects of it. Now, a lot of people think, well, I can't afford to generate all this software. I'm just a small company. I can't afford to do this. Well, a lot of times you can use the software as it exists. It's no different than getting it in a box on a shelf. You pull it down off of SourceForge, whether it's MySQL as a database or PostgreSQL, whether it's OpenOffice. You don't have to change it. But if you feel you do, if you feel it gives you that value, you have the opportunity to change it. It's your business decision. It's your choice, not somebody else's. And people say, well, I've been to SourceForge. There's only about 10% of those projects out there that are really only good, and only 10% of the programmers that are signed up are really doing any work. But that's still 23,000 pieces of software and 200,000 developers, and that's without a lot of other people being on board that's going to grow those numbers. Now, Microsoft has about 70,000 people working for it. That's a fact. 28,000 of those people are in sales and marketing and therefore have no useful purpose. So it leaves the rest of the money. I can say that because I'm in sales and marketing, okay, So you look at the rest of the people in Microsoft, and you say, well, wait a minute, not all those people are software developers either. Some of them are security guards, and some of them paint lines on the driveway, and some of them put software in the boxes, and some of those people take software out of boxes, and hopefully they're not the same people. And and all these things. So when you come down to it, the real question is how many people actually have the name software engineer in Microsoft? And if I was to guess, I'd say between about 3,000 and 5,000 people. And you compare that to 10% of 2.3 million, and those people don't count the coffee breaks, okay, or the vacations or stuff like that.